My research conducted in the VEGERA framework examines the use of renewable raw materials in housing construction, and the research compares model house in Tashkent to a conventional built house in the region. And the goal is to assess how these materials can reduce carbon footprint in buildings. And the relevance of my research is to answer the question if sustainable construction is crucial to mitigate climate change. The building sector in general significantly impacts the environment, mainly through energy consumption and emissions including CO2, particulate matter, sulfur dioxide and carbon monoxide. In fact, nearly 40% of global CO2 emissions are related to buildings, which shows why it is so important to use more sustainable building materials and renewable energy in the housing sector. These general environmental effects can be also transferred to Central Asia and Uzbekistan, because in Uzbekistan, buildings are responsible for more than half of the total energy consumption, which is about 70 million tons of oil equivalents per year, which is a lot even compared to Western standards and European countries. I conducted my research in the frame of the VEGERA project, and from the beginning I was very interested in this project because for me it was a chance to write a master thesis which has some impact and really fitted into my interests, especially because I wanted to do a life cycle assessment for a longer time, and this was the perfect chance to dive into it and learn more about it. So the hypothesis behind choosing these building materials was that it results in a lower environmental impact overall, and that these materials can be sourced locally, and that they also have further advantages, like they provide a nice room climate, and they are also used in traditional Uzbek architecture since centuries. And the VEGERA project tried to build house according to modern standards, but with traditional building materials. There are different challenges when conducting a life cycle assessment in regions like Tashkent, but it's not only about the region, it's also about the building style, because for a lot of classic building materials like sand, stone or burnt brick or concrete, there are a lot of reference numbers and DIN norms, so it's very easy to provide the necessary data or have the necessary source of data for the software, in this case Kala. So it's quite easy to calculate everything, but for specific kinds of timber there is no data, and there is also no data for this quite complicated building technique, because, for example, the walls and the roof, they have a lot of layers and even air layers. So you need a lot of data to calculate the U value of a specific component of the house, and you don't have the necessary data sources. So you have to calculate a lot of data or search for data sources manually, and this is the huge challenge. And then most of the softwares, they focus on regions like Europe or the US, and they work with certain values, for example in the transport or in the recycling stage, and it is not given that the same values and numbers can be applied to Uzbekistan or Tashkent. One example is that you can't choose the weather reference for the region Tashkent. For example, I calculated everything with the weather reference of Potsdam, because the Kala software is from a German software provider. natural resources like wood can help to reduce carbon emissions because in their growth phase they store a lot of CO2, and if you cut the trees and use the timber or wood for long-lasting projects like houses, the CO2 is stored for a long time in these structures. So theoretically, if you build a lot of infrastructure and houses out of renewable materials like wood, you create carbon sink. This is also where the idea of bio-based architecture or CO2 neutral cities comes from. If you also want to talk about the disadvantages of building with wood at this point, then it's also important to mention that the use of trees or timber can be also problematic, since cutting down forests leads to a significant loss of biodiversity and natural carbon sinks. Carla and Ubacus were a great help in my research. I think without these programs, the calculation wouldn't be possible. So Carla is a program that offers full life cycle assessment for buildings, and basically you feed the program with 3D models of the building you are planning. In the second step, you give the program all the informations about the building materials used for each component, and then Carla will calculate the whole life cycle of the building. And you can also give informations like which heating system or which cooling systems are planned. And the huge advantage is that you can, for example, replace certain materials in the planning phase, and then you can take a look how this changes the overall environmental impact. And Ubacus is a program, or it's a online software which is free, which helps you to calculate U values. And U values are really important when you calculate the energy needs of a certain building, because the U value gives the informations about the heat transmission losses. So basically how much heat can pass through certain component of the building, which is really important to reduce the energy demand on the long run, like when you live in the house. My results showed that the project proposal was right, so the VEGERA house has a much smaller environmental impact. In concrete or in numbers, that means that the conventional house has global warming potential GWP of 31 kilograms CO2 equivalents per square meter, and the VEGERA house has just GWP of 15 kilograms CO2 equivalent per square meter, which is a saving of more than 50% per square meter. There are different aspects where the most CO2 is saved. So one big reason is, of course, that a completely different materials are used. So as mentioned before, timber has the ability to save CO2. So every house, or the VEGERA house, turns into a carbon sink basically. This is of course one huge difference, because classic house is built out of materials like concrete and bricks, and especially concrete is super CO2 intensive. And then another huge difference is that even the VEGERA house uses concrete for the point foundations, because Tashkent is earthquake area. You can't build a house there without a solid concrete foundation. But the classic house has a complete strip foundation, which is in total a lot more mass of concrete. So the smart building technique of using a point foundation saves a lot of concrete and therefore CO2, and the house has a far less environmental impact. The next decades, a lot of new houses will be built, and therefore new building regulations like introducing sustainable building styles in Uzbekistan offer a huge chance to make individual housing more sustainable. And projects like VEGERA show that using renewable materials and smart building technique make a huge difference on the long run. And it is also more attractive because the house needs far less energy when you live in it, since the insulation is much better, and this results in lower living costs, which makes it highly attractive for the people to live in these kind of buildings. The VEGERA house has superior insulation properties compared to conventional built house with the same VEGERA geometry. Every component has lower U values than the conventional house, which leads to significantly lower transmission heat losses, which again results in drastically reduced annual heating energy requirements. And in numbers, this is reduction of 84% of energy consumption per square meter compared to the conventional built house. Thank you very much. I hope you enjoyed it.